Hello and welcome. And this is a continuation of our network engineering skills series. This part we're going to discuss the subnetting. Subnetting is very important in network engineering skills. If you want to learn how to plan, design, and implement networks, subnetting is a very important area you need to master. I'll take a quick and shortcut steps to make subnetting really easy. And you would like to answer a few questions in your head when you're going to do any subnetting, and then any pertaining questions from there will be answered very easily. So I put this together. It's quite easy. Actually, it's from my readings. So if you have a subnet, you need to verify what subnet that is. Is it class C? Is it class A, class B, whatever the class is? And then from there, you would decide what you're going to do with it. And that will be the starting point. When you clarify what subnet you're dealing with, then you start looking for answers regarding the block size. You can calculate the block size from this formula. So 256 minus subnet mask. So subnet mask I'll show you how to do. And then you ask the second question, how many subnets are we talking about? And in each subnet, how many hosts are there which are valid? When we say valid, there are two IP addresses which we cannot use, the subnet starting point and the end point. It's called network address and broadcast address. So you have to remove those two. The remaining will be the valid hosts. Then you use those formulas to calculate. And the last question you ask is, okay, I know how many subnets and I know how many IPs are in each subnet, and I know what class that is. So what shall I do next? Then you document the network. You start with the network address, and then you end with the broadcast address. In between, you fill all the other IP addresses from that network. If there are two, you create two subnets. If there are four, they have to be multiples of 2, 4, 8, 16, 32, 64, 128, that way. So if you want to really create subnets, it's easy to put them in tables. And that way, you can put a table with columns and rows. The rows will be your IP addresses, and the columns will be the networks themselves. So if you have one network, then you will have a box of one column and number of rows. So what we're going to do, we will answer these questions by doing this exercise. So first of all, I already put here as class C, but to identify what class this is, you look at the first octet, and the first octet is 192. And from the ranges of IP version 4, if the number starts between 0 and 127, that's class A. And if it's between 128 and 191, that's class B. And if it's between 192 and 223, that's class C. So we already know by looking at the first octet from the left, this is falling in this range, and that's called class C. When you identify the class, the next thing to do is, for class C, what is known with class C? It has to be the first octet, it has to be a network, and then the next octet and a network, third octet a network, and here the last one is where you have your hosts. So I would put a note like N, and then N, and N, and H. And if you do that, the N's will represent all ones in one octet. If they're all ones, that means 8 ones. So if I put ones here, 1, 2, 3, 4, 5, 6, 7, 8. And then the second one, 1, 2, 3, 4, 5, 6, 7, 8. The third one, 1, 2, 3, 4, 5, 6, 7, 8. And then the last one is all H. It's 0. So 1, 2, 3, 4, 1, 2, 3, 4. If you combine, here you've got 8, and you have 8, and you have 8, and you have a 0. If you add them all together, they will give you 24. And that's the class C, original class subnet. So we will have 24 bits, and if you change the binary to decimal, those ones will become 255, and the other one will be 255, and then this one will be 255, and the last one will be 10. So if you want to see how to convert this, please check the other videos I recorded from binary to decimal conversion, and it will be quite easy. Now we know that for class C, we're not going to touch the first 3 octets. What we're looking at is the last octet. Has anything changed from that? That means instead of being all zeros, do you see any 1 or double ones or triple ones, something like that? We don't see any. So here our mask or subnet mask is actually 0. So we call this one subnet mask. We're not calling the whole subnet mask, but this is only our mask. Subnet mask, or just call it mask, is equal to 0 there. So that actually brought us to the level we can answer the questions. First of all, we check the block size, and block size is 256 minus subnet mask. Let's answer that question. And if we do that, the block size, it's the first question. So block size, let's call it BZ, equal to 256 minus the mask, or let's call it subnet mask, whatever you like. And the 256 is the formula, minus mask here, it is 0. So the block size here is 256. Okay, this 256 now, if you look as a block over here. Okay, let me make it a bit straight. So here we have a block starting from 0 to 255. That's if we start from 0. You count from 0 and then up to 255, it gives you 256. But if you start from 1, it will end up to 256. So it depends on where you start. One step ahead, 256. One step back, 255. So if we know the block size is 256, that's going to be our starting point. And this is going to be our last or the end point. So in between, you will have 0. The next one will be 1, then 2, then 3, then 4, continue up to somewhere 128, somewhere in the middle. You continue all the way to 254, just before the 255. That's one block. Okay, so that one block, let me remove that line. Okay, we have one block, and that block is 255 or 256 in normal numbering. In network engineering, we will use the start of 0. So now, if we answer the second two questions, now have a look. It says, how many subnets are we talking about? And how many valid hosts are we considering? So we have to find the on bits and the off bits and label them as H and N, and then use this formula 2 to the power of N will give you how many subnets, and H 2 to the power of H minus 2 will give you the network, the hosts in each network. So let's go here and check how many ones do we have here in this octet. This is what we are interested in. Class C, these are not touched as a classful. We're looking at here, the N, there's no ones here, that means 0. But H, there are 8 of them, 8 here. So now if you use the formula 2 to the power of N, that means 2 to the power of 0. Any number to the power of 0 is equal to 1. That means one subnet. So we answered the first question. The second question, I mean, part 1. And the other one is 2 to the power of H minus 2. And H is 2 to the power of 8 minus 2. 2 to the power of 8 is 2 times 2 times 2. That's 8 times 2, 16 times 2, 22 times 2, 64 times 2, 128 times 2, 256. That's 8. That means 256 minus 2. And you have 254 IP addresses. Now look, if you look at these numbers, the first one is 0 and the last one is 255. If you go to 254, from 1 to 254, that's your valid hosts. So the network is going to be one subnet. Have a look, that's one subnet, and each subnet you will have 254, because the one block of one subnet is 256. And as you remember, we're subtracting the first one and the last one, the network and the broadcast. So we will have valid hosts here, valid hosts per subnet. That's just one subnet. And so if it's one subnet, I'll put a diagram here. Okay, I don't know why the pen is going that way. Okay, so one subnet, and that one subnet, I will start with a diagram like this, and I will call it network. If you have 1, 2, 3, you can call it network 1. This is just one network. And in here, in the rows, you put all your IP addresses. So let's assume the first one and the last one. The first one, look at the network. It starts from 192.168.1.0 and 192.168.1.0. We call it network address. And then the last one, we call it broadcast address. So let's stop this recording here and then start a new session to continue with the rest.